I've been trying to make a video that explained how the oscillators work in Affinity Photo's procedural texture filter. And it seems like just about the time I think I understand how they work, it turns out I don't really understand how they work. So I'm going to try it again, and this is a filter I wrote. It's a polynomial, and I can change the parameters here to have different effects. I can make different stripes. I could control the slope of these and change the angle of them. And I could also even introduce some curvature to this for some other effects like that. So I'm going to go back to the beginning and look at how this works and try to explain what's going on here. So to do that, I'm going to just cancel out of this. I'm going to close this image, and I'm going to create a new one. And I'm going to set it up to be 1000 pixels by 1000 pixels. Create that. Now I have to add a pixel layer, and I need to fill it. So I'm just going to fill it with black, like that. Select it, and now I can go into my filters, colors, procedural texture. And the first thing I want to look at is this checkered filter. So there's checkered. If I look at the formula for this, I see it's osci, oscillator I, parentheses, times Rx, or parentheses, Rx times C divided by W, and Ry times C divided by W. Now I know Rx is the relative X and Ry is relative Y. And I know that W is the width of the document, so I'm dividing it by W for some reason. And I know that I'm multiplying by C. And I know that that somehow scales it so that as I change C, it changes the number of squares that I see in here. Okay? But what I really want to understand is, why does that work that way? Why does it have this effect to change that? And I sort of know, because I know how the oscillator works a little bit, but I want to look at that in detail. So here's a square count of 2. So to do this, I'm going to start over with a blank, reset to empty, and add an equation, and I guess I'll add a for this now. And I'm going to just start off with oscil I, and I'm going to try the simplest form of this that I could think of. And if you look at the documentation, you'll see that oscil I, or oscillator I, or I think I'll call it osci. Osci can have either 1 or 2 parameters or a vector. So if you can give it just one value. So I'm going to put down one value, 0, and that's my input, osci I. So let's see what that does. Okay, so that makes it red. Now I could turn on all of these, and then it's white. So if I put in a 0, it generates a 1 as an output. And it generates it for all the pixels in the drawing. Okay, so that's that one. What happens if I put in a 1? Okay, then it goes black. All right, so if I put in a 2, it's white again. So if I put in an A up here, I can change it black, white, like that. And if I go negative, let's see, there's 2, 1, 0, negative 1. So it goes backwards like that. So where does it change? So if I put in a 0.5, it's still white. At 0.9, it's 0.9, it's okay with that. It's still white. So, or if I go to 0, it's white. But as soon as I go over to minus 0.1, it switches to black. As soon as I go up to positive 1, it switches to black. So between, if I have real values or floating point values between 0 and 1, it will be white. If it's between 1 and 2, it'll be black. Okay, so that's the way it works. And so it doesn't just have to take integer values. It can take a floating point input or a fractional value input to this function. So that's why, so I'm going to try something else. I know that x represents the x pixels, all of the pixels in my drawing. So if I put an x in here, I get this sort of noisy image. But if I zoom in on that, I can see, yeah, that's doing exactly what I thought. When x is 1, it's white. When x is 2, black. 3, white. 4, black. So x goes from 0 and this way, counting up one at a time. I could, so that's that. What if I divide this by 2? So now, like that. So now it's 2 pixels are white and 2 are black. So if this goes from, x is going from 0 to 2, but since I'm dividing it by 2, now the input to the osci is 0 to 1, right? And so then it makes that white, and then when x goes from 3 to 4 divided by 2, that's 1 to 2, right? And so that's black. So that's how that's working. I could add a y component over here, and the y is going every other one in y. And now if I divide that by 2, I have my checkerboard again. Now this is pretty small. It just makes sort of a noisy image for me because that's too small. So I could do a bigger number here. Let's do 100. Now I made my document 1000 by 1000. So when I divide each of these by 100, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different squares in my image. And each one is 100 pixels wide. Okay. Now if I divide by W, I just have one big square. But if I take, let's say I divide by 1000, but multiply by 10. So that's sort of the same as what I had before, right? That's the same as, let's see, times 10. So that's the same as dividing by 100, right? And so it didn't change. If I multiply by 8, then I get 8 squares. Okay, so in general, I can divide by the width of my document, my image, and if I multiply by some other factor, it'll divide it into that many pieces of checkers. Okay, so as I multiply by this, a factor, it'll add those in. Now, because I chose just x and y, I can't move this. So that's the first part.